All right, we're going to go over an example argument, and we have the argument written out in words here. We're going to translate this argument into symbolic, into a symbolic argument, and then prove that it is valid by applying rules of inference. So the question is this a valid argument? Now, in order to do this, we're going to use, I'm going to use these individual propositions. So these are our little individual propositional variables. These are the individual things that can be true or false in this argument. And then we're going to express it symbolically and prove step by step. Now, this document is on D2L, so if you want to print it out and go over it with me as we go through, you could even try it on your own first, see what you think, and then watch the video, continue watching from here to watch me do it. So let's read through the argument, and we're going to translate it into symbolic statements. Bob works part-time or full-time. So we could say that as, rephrase that as Bob works part-time or Bob works full-time. Bob works part-time is the variable P, and Bob works full-time is the variable F. So I'm going to label this 1, premise number 1, and it is P or F. All right. 2, if Bob doesn't play on the team, then he doesn't work part-time. Okay, this is an implication, right? If, then. What's the hypothesis? If Bob doesn't play on the team. All right, well, Bob plays on the team is one of our variables. It's T. So that means the hypothesis here is not T. All right, if Bob doesn't play on the team, then he doesn't work part-time. So that would be not P. All right, 3. If Bob plays on the team, so that would be if T, then he is busy. Bob is busy is variable B, so T implies B. And then lastly, premise 4, Bob doesn't work full-time. Great, so that's just giving me like the value of one of the variables, just straight up. Bob doesn't work full-time. It's saying not F. So I'll write that, not F. If not F is true, which is what we're going to be assuming, right? Because we're going to assume all these premises are true. So if not F is true, then F must be false. All right, so that's going to be our, So that's going to be something we can possibly work with. Therefore, Bob is busy. So we'll conclude this here with therefore B. All right. Okay, so now proof of validity using rules of inference. We're going to assume all of these premises are true. Okay, so we're assume 1, 2, 3, and 4. And then what I'm going to show you how to do is a way that we can conclude things based on applying our rules of inference. So I have our rules of inference sheet right here. Okay, so I'm going to kind of be pulling this up and using this along with what we have here to complete the proof. So first of all, we're going to assume 1 through 4. Okay, so now I'm gonna label each step in my proof with another number, and then I can actually refer back to those numbers if I need to. So 5. Let's see what we can do. I know I said if we're assuming not F, then we might be able to get F is true. That would be one way to do it, but I'm going to show you a different way. That way, I wouldn't really use rules of inference. What I want to show you is how can we like apply. How can we apply combinations of premises to make new conclusions? So we are gonna latch on to that not F, okay? Because that's a great starting point. That's something pretty significant. But if not F, and we also know P or F, looking through here, that looks really similar to disjunctive syllogism because it says P or Q and not Q. So, or sorry, P or Q and not P is what it says, and then you can conclude Q. So this is essentially saying P or F has to be true, but it's not F. Therefore, it's got to be P. That's a disjunctive syllogism. So I'm going to write that we can conclude P, all right? And that is a disjunctive syllogism, which I'll abbreviate DS, of premises 1 and 4. So essentially what I'm saying is I'm justifying the conclusion of this in this step, which is P. I'm justifying that conclusion with the type of rule of inference and then the particular previous previous statements that are being used as the premises for that rule. So 1 and 4 are the premises, and disjunctive syllogism gives us this conclusion. All right, so let's move on. Now that we know P, maybe what we could do is do something with number 2, right? Because number 2 says not true implies not P, right? So we don't know not P, we know P, but isn't that not P? Let's put a step in here where we write P as not P. Now this is not a rule of inference. This is actually just like a propositional equivalence. We're going to use a double negative of 5. So this is something you can do along with using rules of inference. You can use the equivalences to just rewrite statements. So that's double negative of number 5. Now, not P is the negation of the conclusion in this premise number 2, right? So going back to our reference sheet, if you know an implication and you know the negation of the conclusion, that's modus tollens. So we can actually conclude the negation of the hypothesis, right? Remember that modus tollens is basically like combining modus ponens with a contrapositive equivalence, which would be another way we could have written this out, by the way. So I'm going to get to conclude the negation of the premise of number 2. So sorry, of the hypothesis, so not T. That is modus tollens of 2 and 6. Now, not T is going to be just T, right? That's a double negative again. All right, so now we know T. Now, well, if we know T and we also know T implies B, then we should be able to conclude B. That is modus ponens. P implies Q, and P means you can conclude Q. So, here we have, for number 9, we can write B, and that is modus ponens, MP, modus ponens of statement number 3 and statement number 8. And then that actually is what we were trying to conclude. So we can say, hey, assuming these premises and then applying rules of inference, we were able to deduce the conclusion that it says that you should be guaranteed, and therefore, the conclusion is true. Therefore, the argument is valid. And there we go. So that is our first example. We're gonna, in the next video, go over another example, and then we're gonna use predicate logic for the second one.